Alright, so exercise 4K from Patel, question 11, gives us two complex numbers, and plotting them on the Argand diagram will help us see what's going on here. So we've got the number 1 minus 3i there, and we've got the other number minus 3 plus 4i, and then that forms our two numbers here of interest, and those two numbers are P is this one down here, Q is this one up here. Now we require R to get a right angled triangle, which is going to give us one there, and it's also going to give us another one out here, and they don't form a rectangle, and the reason is because the question requires R to stay on the real axis. So there's two values of R there, a positive x value and a negative x value, with the y value being 0, of course. So in order to find those, R is movable, and you need to find R1 and R2, but if we leave it in generic form, we should be able to find both values of R. Now we get, because they're perpendicular, we can just use the perpendicular rule to find that, or you can also use the vectors one being multiplied by ki to get the other one. But the perpendicular rule is easier, so we'll do that. So we've got MQR being equal to, so the gradient of QR is 4 minus 0 over minus 3 minus x, and the gradient of PR is equal to PR, so it's 0 minus minus 3 over x minus 1. So that gives us 4 on minus 3 minus x, and here it gives us 3 on x minus 1. Now those two things need to multiply together to be equal to minus 1 to meet the criteria of them being perpendicular, and therefore we get 4 on minus, in brackets 3 plus x, times by 3 outside of x minus 1 being equal to minus 1. And what I'm going to do at this point is flip everything, because there's a product on the left hand side, and so I get x minus 1 times negative 3 plus x on 12 is still equal to minus 1, because the inverse of minus 1 is still minus 1. That gives us then 12 on the denominator, and on the numerator I've got x times 3, which is 3x, plus x squared, minus 3, and minus x. All of that has the minus out the front, because I didn't use the minus in timesing. And that's equal to minus 1. So if I times both sides by negative 12 now, I get x squared plus 2x minus 3 equals 12. I get x squared plus 2x minus 15 equals 0. And solving this, I get x plus 5x minus 3 equals to 0, and then I get x equals minus 5 and positive 3, and those two values of x are the two values of R that make that statement true about them being a right angled triangle. So the point, find a point R on the real axis, well there's 2 points R, so R is 3, 0 for the one up here that we said was R1, and R2 over here is minus 5, 0. And that's the easiest way to solve that one.